Okay, so we're going to cover two sections today, 5.5 and 5.6. One of these sections y'all have already tested over, but y'all need more practice on, so it's thrown in there. But what we're going to start with is finding zeros when you are factoring it, okay? So instead of me just giving you a calculator, hey, graph it, find the zeros, and copy a table down, we're going to do higher degree factoring, okay? So remember if way back when we were doing quadratics and we would talk about if you had a double solution, and I always showed y'all the graph of a double solution. What happens with a double solution graph? It bounces off, okay? And how do we know it's a double solution? You have two of the same, and so it bounces off. So right here, these two little bullet points is telling you that when you have a factor and it's raised to an odd power, so if you just have it listed one time, or if it's to the third power, then it's going to cross the x-axis. But if you have that factor raised to an even power, so x plus 7 squared, you would get x equals -7, and you would get a double solution right there. So when you have it raised to an even power, it's going to bounce off that x-axis. So I put that there because what we're doing is we're not using the calculator at all. We're finding our x-intercepts, and we're using our end behaviors, and we're using what we know about crosses versus bouncing, and that's how we're going to predict what the graph looks like. Okay, so your graph is not going to be perfectly accurate, which is fine. I just want to see if you understand what the shape should be. Okay, so remember that your odd degrees, if your the degree of the polynomial is odd, they go in opposite directions. So remember those end behaviors, okay? And if it's even, they go in the same. Odd, opposite, even, same. So what we're going to do is we're going to start with 2x to the third minus 12x squared plus 18x, and we're going to factor that, and then we're going to sketch it, okay? So if I have 2x to the third minus 12x squared plus 18x, what do I do with it first? I need to take out a GCF. Now remember that I'm going to eventually get x values, right? I'm solving for my zeros. So I'm going to take out my 2x, factor that out. That leaves me with x squared minus 6x plus 9. But now I've got to have it equal to 0. That f of x is my y, and for it to cross the x-axis, my y has to be 0. Alright, so now I need to factor x squared minus 6x plus 9. I'm leaving that 2x out front, and what does what's inside parentheses factor to? X minus 3, x minus 3 equal to 0, or if you know, it could be 2x, x minus 3 squared equal to 0. Either way, I'm good with. Alright? So 2x equal to 0 will give me x equals 0, and x minus 3 equal to 0 is going to give me x equals 3, but what's special about that one? It's going to give me a double solution. Okay, so at x equals 0, is that going to cross or is that going to bounce? It's going to cross because I didn't have a double solution. So with x equals 3, I have a double solution, so that means it's going to bounce. So I'm going to plot my points. Okay. Now if I'm looking at my first term, 2x to the third power, are they going to go in opposite or the same direction? It's in odd degree, so it's going to be opposite. My leading coefficient is positive, so that means does it start or end positive? It's going to end positive. It bounces, but I start negative. Okay? It does not have to be accurate. You just need those attributes on your graph. So it's going to start negative. It's going to cross at 0, somewhere come back down, touch 3, bounce off, and go to positive infinity. Okay? If your height of whatever happens here is different than mine, so be it. We're not looking at the graph. We are just predicting what happens here. Okay? Are good? Okay, so now I have negative 2x to the 4th plus 16x squared minus 32. Do I have a GCF? What is it? 2. Now, yes, negative 2. I have a leading negative. I'm going to go ahead and factor that out. So I'm going to have negative 2, and that's going to leave me with x to the 4th minus 8x squared plus 16 equals 0. Alright, now when we factor x to the 4th, think about what you do with x squared. X squared splits into x and x. So x to the 4th is going to split into x squared and x squared. Okay? So just because you're not used to that doesn't mean you can't do it. Okay? So I'm still going to take factors of 16 to give me a negative 8. I know this is x squared. I know they're the same signs. Hopefully you know what this is. It's going to be the same. So you can write it negative 2 x squared minus 4 squared equals 0. But what do I know about x squared minus 4? It's the difference of 2 squares. So this is really x plus 2, x minus 2 squared. So if you don't want to do the squared part, if you feel like you're going to get confused, then don't do that. Keep it like this, break both of them down. But you should be able to recognize that's going to make these two both double solutions. Okay? So my two zeros are going to be what? Negative 2 and positive 2, and both of those are double solutions. So they're both going to bounce. Okay, so I've got my negative 2, I've got my 2. Okay, my degree, is it even or odd? Even. My leading coefficient is negative. So what do I know about my end behaviors? They're both going to go down. So I start down, I come up to negative 2. Am I going to cross or bounce? Bounce. Go down, but then somewhere I'm going to have to come back up. Bounce again. Okay? Make sure you have arrows. Okay, y'all good with that? It should be easy. Okay? Alright, without graphing, find all of the zeros of the function. What is that telling me to do? Just factor it. Okay? So, before I can factor, what do I need to do though? Alright, so it's 2x to the 5th minus 14x cubed plus 24x equals 0. Okay, to factor it, what am I going to do first? And that leaves me with minus plus equals 0. So I have 2x, and then what? Equals 0. So I'm going to have 2x is equal to 0, x squared minus 3 is equal to 0. Now this x squared minus 4, I've got to break it, factor it further. X plus 2, x minus 2 equals 0. I want to see, if it is a difference of two squares, I want to see you factor that. I don't want to see you do that square roots. Okay? So then x plus 2 equals 0, x minus 2 equals 0. So x equals 0. X squared equals a positive 3, so square root it, and that gives me plus or minus square root of 3. Then x is equal to negative 2, and x is equal to positive 2. So how many zeros do I have? Nope. 5, because it's plus or minus. Okay? The number of zeros you have should match your degree of your polynomial. Okay? Now, this next section is what y'all did. Y'all did just test over it, but we need some more practice. Okay? Again, yes. Okay.
That's basically what you said.
So typically, every year, there needs to be more practice. So, if I give you 4, negative 1/3, and negative 2, I'm writing a function. If it tells you write a function, what should you always have? F of x. Now, if this is telling me 4, what does vectored form become? What does negative 1/3 become? Okay, and then, all right, so we're going to multiply. That gives me 3x squared. Then I get a 6x plus x, which gives me 7x plus 2. Okay, so then I get 3x cubed plus 7x squared plus 2x minus 12x squared minus 28x minus 8. So my final function will be what? Very good. So, no one typically gets that wrong. Okay, but we need some work with our imaginaries and radicals. Okay, so the next one I have a 2, a negative 5i, and a 0. So I'm going to have f of x equals, I'm going to put this x first that represents that 0. And then I'm going to have x minus 2, and then I'm going to have, okay, you better have its conjugate there. So then I can multiply and get x squared minus 2x, and then the conjugate gives me x squared minus 25i squared. Okay, that cleans up to x squared plus 25. So when I multiply, what do I get? Plus, minus, minus. Okay, do I leave it like that? Okay, Okay, what's my final answer? Y'all kind of dropped off and I couldn't hear y'all, but I'm assuming all you did was switch those two terms to put it in standard form. Okay? It's easier the second go around. All right. This example 6. I have f of x equals Okay, so remember that you're changing these signs. So if you struggle with that and you need to write x equals 2 plus square root of 5 to know that becomes negative, this is always a plus or minus, so you take care of both of those anyways. But that 2 being negative is your key there. There were a lot of people that did not fix that on the test. Okay? You have to change that sign to become negative. Alright, now, what do I do? So remember that we used that conjugate concept, x minus 2 squared minus square root of 5 squared. So x minus 2 squared is x squared minus 4x plus 4. Then you have minus 5. So I have x minus 3 times x squared minus 4x minus 1. So when I factor it, it becomes minus plus. Okay, final answer in standard form. Okay, I want you to do example 7. what do I start with? So that would give you a plus 9. Okay, so if you need to write this out so you don't mess up this sign, that happened a lot also. 2i squared does not become, okay, this is going to sound the exact same. 2i in parentheses squared does not become 2i squared. That becomes 4i squared. I got that a lot also, okay? That becomes 4i squared. 4i squared becomes negative 4, so negative 4 is that plus 4. Okay? If y'all can hear the number of times he said 13. Yes, ma'am. When you write x minus 3 twice, you get your negative 3x, negative 3x. He does the wrong order.
No, I just said plus 13, x plus 3x minus 3. I just went straight to the answer.
Did y'all say plus 39?
Yes.
Okay.
X cubed minus 5x plus 39.
So basically what I told you earlier, you should have the degree of the polynomial, that is the number of solutions you have. That's the number of zeros you have. So if I have x to the 5th, I have 5 zeros. If I have x to the 20th, I have 20 zeros. Okay, now they aren't necessarily all going to be real. Okay, so if I have 2x minus 1 equals 0, that's a linear equation. My degree is 1. I have one solution. I would have one x-intercept, which is 1/2. Okay, if I have x squared minus 2, my degree is 2. I should have two solutions. You get x equals plus or minus square root of 2, so that plus or minus takes care of two solutions. Okay, same thing, y'all can see the pattern. Okay, so we're going to look at 4x squared minus 5x to the 4th plus 3x minus 2, and how many solutions does that have? Why not 2? Alright, it's really, in standard form, negative 5x to the 4th plus 4x squared plus 3x minus 2. So I should have 4 solutions. We're not going to figure out what those are just yet, but you should be able to identify that. Okay? So this fundamental theorem of algebra brings us to Descartes' rule of signs. Okay? So what we're going to do is we're going to predict how many possible real and imaginary solutions there are. Okay? So what we're going to do is look at our original function, and we're going to see how many times does the sign change, because what does that sign change mean? think about, how do I get an x-intercept? It has to cross the x-axis. Well, what do you need for it to do? You have to change your y values. So we're going to use the change in this function, the change in signs, to predict how many possible real solutions there could be. Okay? So if I go from a positive x to the 6th, it changes to negative. Then it changes to positive. Then it changes again to negative, and I don't have another change. Okay? So this original one is going to tell me how many possible real zeros there are. So for my positive real zeros, there were 3 sign changes, right? Now what you're going to do to find the possibility is you're going to start at that number and you're going to count down by 2s until you get as close to 0 as you can. Okay? So I can have 3 or 1 positive real zeros. This is almost like probability. It will all make sense when you put it together. Okay? So after you look at the original function, you're going to figure out, if I take that x and make it negative, f of negative x, we're going to see how many possible negative real zeros there are. Okay? So I'm going to take negative x to the 6th minus 2, replace x with negative x to the 5th, plus 3, negative x to the 4th, minus 10, negative x cubed, minus 6, negative x squared, minus 8 times negative x minus 8. Okay? And we're going to clean it up. You're not going to have to write that out every single time. I'm about to tell you all the shortcut. Okay? If I take a negative and raise it to the 6th power, what does that give me? A positive x to the 6th. Now, I have a negative 2. What is negative x raised to the 5th power going to give me? Negative x to the 5th. So negative x to the 5th times negative 2 is a positive 2x to the 5th. Now negative x to the 4th is just x to the 4th. So that stays plus 3x to the 4th. Then this negative x cubed times negative 10 is going to be, and then negative x squared is x squared times negative 6 x squared. And this becomes plus 8x minus 8. Okay? So, what's the trick there? Do you notice what's happening? The odds will change signs. The evens do not. So I could go straight from here and recognize x to the 6th, whether it's positive or negative, it's raised to an even exponent, it stays x to the 6th. This, x to the 5th, is an odd. It's going to change signs, so that negative 2 becomes positive 2x to the 5th. 3x to the 4th, it's an even exponent. That stays the same regardless of what my x is. Negative 10x cubed, it's an odd, so it's going to change signs. This is going to stay, that's going to change. Okay? So if you need to write this step out, that's fine. But I'm okay if you go straight to this. But if you mess up, and everything else is going to be wrong. Okay? Alright, so that's going to be, we're going to do the same thing, and we're going to count how many possible negative real zeros we have. So I go from positive to positive to positive to positive. I only have a change in the sign going from x cubed to x squared. Then I go back to positive, then I go back to negative. So I have 3 possible choices, or 1. Okay? So I'm going to now have to make a table, and I'm going to put it all together, and these are my possible options. So this is why I compared it to probability, because you have multiple different things you could do. So I could either have 3 positive real zeros and 3 negative real zeros, or I could have 3 positive and 1 negative real zeros, or I could have 1 positive and 3 negative real zeros, or 1 positive and 1 negative real zeros. That's just my reals, not including imaginary. Okay? It's really not hard. So what you're going to do is you're always going to have 4 columns. You're going to have positive, negative, imaginary, and total. Hopefully you do a better job at spacing yours out than I do. Okay, now the number of rows you need, so I always build my columns with my header. The number of rows you need will be the number of choices for your positive times the number of choices for your negative. So I have 2 choices and 2 choices, so I should have 4 rows. Now, using the fundamental theorem, my degree of this polynomial is what? 6. My highest degree is 6. So I should have 6 zeros no matter what. Okay? Now this is where I was talking about. My positives, I can have 3 positives and 3 negatives, or 3 positives and 1 negative. Y'all follow me? Now that it's in a table, visual format. Or I could have 1 positive and 3 negative, or 1 positive and 1 negative. Alright, well how do I know how many imaginary? I figure out how many else I need to get to 6. If I have 3 positive and 3 negative, I don't need any imaginary. But I have 3 positive and 1 negative real zeros, then I need how many? 2, because that's 4. So then if I have 1 positive and 3 negative, 2 imaginary again, 1 positive, 1 negative. Okay? So all my instructions told me was to determine the possible ones. It doesn't tell me to solve for them. Okay, so this would be what I'm looking at. You don't have to break down that long polynomial. You just have to predict. It's not hard. Okay? Alright. So for my positive zeros, I go from positive to negative, and then I go again to positive. So 4, or 2, or 0. You go all the way down to 0. You count down by 2s till you get to 0. See, earlier we were odd, so I couldn't get to 0. It was just 3 or 1. Okay? So now I'm going to do f of negative x to look at my possible negative real zeros. Can we do the shortcut? Alright, it's going to become negative x to the 5th, stays negative 3x to the 4th, minus 5x cubed, minus x squared, plus 6x plus 4. Do we all understand how we got that? Okay. So then sign changes don't happen except for that one time. So my possible negatives are just 1. I have exactly 1. Okay? So I'm going to build my table. If you need a ruler to build the table, go for it. How many rows do I need? Well, I only have exactly 1. 3 times 1 is going to give me 3. I either have 4 positive and 1 negative, 2 positive and 1 negative, or no positive and 1 negative. But no matter what, how many total do I need? So if I have 4 positive, how many imaginary do I need? If I have 2 positive, 1 negative, I need, and then so that's my possible combinations. Okay? Alright, so you've got your worksheet to work on. We are not going to have a quiz over this. Okay?